Hello everyone, today is March 6th, 2022. I am going to, review some problem I have finished before. This problem sort array, and last time I implement the merge sort with iteration, method. This time I will try to do the quick sort. So the sorting issue is simple, so just array and sort it. I am going to, use my favorite editor to do that again. And let me check. So the quick sort.c. Okay, as the the quick sort algorithm, that's basically partition array. And let me open the print. Okay. Okay, so basically that's an array, and we choose anyone. Usually I will choose the end of the atom, that one, and I will scan everyone from 0 to the n minus 1. And I will compile one by one. So any one is greater than that one, I will swap over there. And any one less than the powered, we will keep moving. So basically, when I'm searching the I right here, so any one before the I, there will be less than the powered. Anyone greater than I from I plus 1, that will be greater than the powered. Later on, I just swap, the last one and I plus 1 and return I plus 1 for the array. So that's the partition, and we recursively call the function to there from part and the former part and that part, the latter part, and finally we got the sorted array. That's my idea for the quick sort. Let me do the implementation. Before that, I will load the default code definition and copy that. Okay, so get one, I will going to do partition. Yes, partition will get the numbers, the left and the right. Maybe low is high is better, so low and high. Okay, so for the partition, let me think. So I will definition for the I index for the loop, and I also need index, and also the powered. Okay, initialization index equals low minus 1. Okay, so the powered equals num array high. Okay, so for I equals 0, no equals low, and I less than high minus 1, and I plus plus, we go the for loop. If numbers I less than powered let me think. I'm going to do greater than power, we do swap. So in that case, we just swap I and index. Let me think. Let me think. So anyone we get the one, we will go to swipe, but let me define another one for the swap function. I'm going to define a function for that. Okay, that's the swap. So okay, so I'm thinking I will swap the last one over there. Okay, that's one. Once the one less than the powered, we will swap numbers index plus index and numbers I as well. Yes, else after the for loop we will swap numbers I plus 1, no, index plus 1 and numbers high as well. And after that, we just return index plus 1. Yeah. And in the sorted array, I'm going to define another sorted array. And int numbers and int low and int high. Definition. So I will call the, let me think. Okay, I will define the pivot and which equals partition numbers 0 and low and high. Okay, so and we just do recursion numbers low to pivot minus 1 and sorted array numbers low pivot plus 1 to high. Here we go. That's the one. And for that one, return size. I will do return size equals number size and call the sorted array input numbers and 0 to number size minus 1. Here you go. And later on, I just return numbers. Yep, pretty much. That's for the quick sort. Let me try to run it in the Leetcode. Okay, run code. Okay, we don't need return for this recursion sort. So I'm going to run that again. Okay, that's some boundary over the heap. Let me check. First one, I'm calling to that for the numbers 0 and the numbers minus 1. Okay, and I call low and power 1, the low and the power to plus 1 to high. That will be fine. And for that one, let me see. So for some cases, what's the task case right here? 5, 2, 3, 1. And for the index, I will do index plus 1. Let me think. So I'm not sure if that we could call this one, but I will do plus plus here and the numbers plus index numbers plus I. We swap number plus index plus I and numbers plus high. Okay, let me check. So let me print something out to see which part is going on is wrong. So I have no idea which part is wrong, but basically I could do print here to get a big idea. Okay, 0, 3, 0, minus 1. Why high could be minus 1? Partition, partition. Okay. Okay, in that case, we need do one thing. We need to check if low less than high. We will do all this stuff. Okay, I got the right answer. Let me comment this one out and submit. Hold on, why I got the wrong answer? So first time that will be 0, 3. Second time will be the 1, 3. I expect 1, 2, 3, 5, 1, 2, 5, 3. I swap 1 and a high, that will be fine. I try to enable some debug to figure out which part I am wrong. Okay. 1, 2, 3, 5. Okay, 253. 253 is not right. Okay, that means, okay, the second part will be 253. 253 means, 253, that will return. Okay, oh, that's fine, right? That's from low to high, and we do that one. Same thing, low and high, we do that one. That's no problem. But how? And after return, return, return 0. Okay, return 0. And for the 2 file 3 and the 2 file 3, that's return 2. Return 2. Oh, that's the case. So for the recursion, we don't do this, that will be fine. That's fine, right? I got right, so that return 2. Return 2 right here. Return 2. 2 means here. 2 means 5. Okay, 2 means 5. That's fine. And that's return 2. Okay, in the 2, so they will do sort. They will do sort from 1 to 1, 2, 3, 4, 5. So we do, hold on. So partition, let me check partition. So when I checked last one 5, we search 2, the 5 and 3. We search 3. Numbers I, let me think. Numbers I, okay, 2, 3, 5. Numbers I less than 5, less than 5. Okay, so, okay, first one, 2 with 5, so we will swap 2 with 2, so that's fine. And 3 with 5, so we'll swap 3 and 3. yeah. We, it seems we don't expect 5 and 3 swap happen. Hmm. Return 2. High is okay. 0 3 return 0. 1 3 return 2. 1 3. Oh. 1 3. 1 3. Let me think. So 3 1 3 0 1 3. So that will be numbers pointer plus 1 and plus 2. That will be 2. Okay, hold on. If numbers I less than powered index and I, okay, so that's the one, and the index is 1, I is 1, so we don't do swap. We don't do swap. And for the last one, sorted swap. And for the last one, so let me print out here, index and high. Index high I and 3, so I1 and 3, I2 and 3 swap. 2 and 3 swap. 2 and 3 swap. 1 and hold on, something wrong. So for the 0, 3, the whole we try to get a partition. Partition is 1. And the 1, number 0 is less than 1. It's not. It's greater than that. So we start 2, 3. Nothing changed. Oh. Okay, we just swap 1, 5, 2, 3. How that happen? How 1, 2, 3, 5 happens? weird, huh? So I'm going to expect for the first time that's only 1523. How does 1235 happen? That means 1523. 1523. Return 0. How we return? Okay, that's return 0. Okay, that's fine. But how 1235? Hmm. Okay, 5231, that's fine. And 1235, how that happen? We only swapped 1 and 3, 1 and 3, 1 and 3, 2 and 3. So that means, hold on, how that happen? We only swap 2 and 3. That means 5213. How that I got 1235? Hmm. Hmm. Okay, that's the one. And in that case, I will call the partition. Let me see, partition is the right. So low on the right. Okay, partition, that means 5, 5, 2, 3, 1, that's right. And to the partitions, 5, 2, 3, 1, call the first time call partition, 5, 2, 3, 1, that's right. And after that, we just got 1, 2, 3, 5. That's really interesting. So we only do one swap. One swap is 2, 2 and 3, 2 and 3. How that happen? So first one, we got pivot is 1, and we check numbers 0, 0 to 5. So let me copy this one. 5, number 5, that's 5 with 1, and 5, okay, we go that one, then we go 2 and 1, still go there, and we go 3, 3, 2, 3, oh, hold on, so, from low to high minus 1, we equals, less than equal, high and minus 1, but how that happen? We go 3 and 1, we do nothing, then we change index. Index is minus 1. Yeah, index is minus 1. And we do 0, so we swap 0 and 3. Swap 0 and 3. And we got 2, 3, 5. So swap has the problem. So the dot tab. Okay, just to switch. Okay, first one we swap minus 1, 3, so we got 5, 1. That's right? So we swap 5 and right. How? Yes. Okay, that's right one. Hold on. Oh, stupid. So that's 1, 2, 3, 5. That's right. Next time we search 2, 3, 1. That's accepted. That's lost. Okay. Then I insert that one. Okay. That means they don't accept quick sort for that one. And oh, we need a random. Okay, as I said, so we hit time limit exceeded problem on this example. So I open that here. It looks like it's already sorted. The sorted array, and for the quick sort, the sorted array will be the n square, big O n square time complexity. So to resolve this, I know we have to do the random partition. And I don't remember the C language random partition, but the function, but I Google it and learned before I restart this session. Okay, so the partition we could do this. we could do some, let me recall, so int, so return int, and the partition R, and we do same thing, int input array low and int high. In here I will do I will call an index. Index equals 0, now equals low, and I will random to sign time now for the random seed, and the index will equal plus random r mode by high minus low as well. So that's the one, and after that we just swap numbers, index, and the numbers high. And later on we just return partition numbers low and numbers high. Okay, in the calling for the recursion, we just call partition random function for that. So here we just make sure we got random partition to get the speed up the quick sort. Yep, let me check. Run the code. Okay, that's syntactics issue. So let's run again. Line 4. Okay, that's the wrong one. So I do need where it is. Okay, that's the wrong call here. Okay, here we go. Your input, output, expect, that looks right. So I go to submit again. That's accepted, and faster than 35%. Let me do a submit again to see what's the difference. Oh, it's lower. It's lower. Okay, so I think I got accepted solution and summarize. I do here, that's fine. And the partition, let me see, I do anything change. I thought change the swap, the parameter, the swap function, the input parameter to the integer pointer to call the pointer plus his increment. And the swap here, I don't really recall I changed anything here. One is I call the random one, so to get the random powered, to make sure we don't hit the quick sort worst case. After that, I just recursive call that. It's basically one, and that's what I'm doing. Okay, that's pretty much. Best case is 35 bits, 35 C subtraction. Okay, I think that's all for today.